Well, how's it going out there, folks? Rooster here in Tennessee, roostercb.com. And I guess you could say this will be part two to our little Coax discussion video I did a couple of days ago. And this is a Coax loss calculator. And you can probably find some better ones online, maybe some more up-to-date ones, some that have a little bit better selection of a Coax cable. But this one will probably be good enough for what we're going to do. We'll just do a few comparisons here and kind of visualize, I guess you'd say, how much loss you can actually have in regards to the type of coax you use. And again, as someone pointed out in the comment section on the other video, that can not only be your transmit power, but, you know, obviously it can have a little bit of an effect on your receive as well. You might wonder why your neighbor hears somebody that they can barely hear and you can't hear them at all. Not always the case. Could be location, could be antenna, but it also could be your coax, as all that stuff does factor in. So this one is a little bit outdated, I'm not going to lie, but it is one of the easier ones to use. Here's your link up here in the top, and you've got all kinds of different cables. Probably the more common ones that we see every day are like the RG8X, RG213. Then you've got your LMR type cables here. And also note, these are going to be solid conductor cables. These aren't going to be the Ultraflex. Now the difference that makes, these cables do handle a little bit more power and they do have a little bit less loss. It's not super crazy, the loss difference on them. But they are going to perform a little bit better. So keep that in mind. Our results when we put them in the calculator could be a little bit skewed. It's not quite going to be, you know, the loss is not quite going to be, the flexible cables, if they were on here, would have a little bit more loss, is what I'm trying to say. And then down here, we'll use these for our Helix type cables. LDF4 being the 1/2 inch. Again, LDF4 has been discontinued and is now AVA4. LDF5 is going to be the 7/8, and it is now AVA5. Again, this one's a little bit outdated, but it will work to kind of get the point across for what we're trying to demonstrate here and discuss. So what I would like to do first is we'll come down here to our calculator, and we're going to start with 100 feet. 27 megahertz is where we're going to be, because that's the CB band. That's what we're kind of focused on here. And for our first little coax comparison, we'll just do 1,000 watts, and we will select, let's just start with the small stuff, RG8X. So we got 100 feet run. We're running 1,000 watts into it, RG8X, pretty small coax. And by the time we get to the end of our run, or to our antenna, we're only getting 700 watts to the antenna. So, approximately what, 2/3 of our power is getting out to the antenna. 70% of our power making it out to the antenna. Now, let's compare that to a comparable coax, something like our LMR 240. And keep in mind, this isn't the flexible stuff, so it's going to be skewed a little bit. Even so, we go from what we're at, 700 watts to 746 watts. So it makes a little bit of a difference. Now, on a 100-foot run, a lot of people like to use 213 up to about 5,000 watts. So again, I prefer the LMR 400 coax, but we can use RG213 just to kind of experiment. So the RG213, you get about 40 more watts out. Now to me, that is not all that impressive when compared to a small coax like that, as 213 is a good bit bigger, that you only gain about 40 watts. Going from about 75% up to about 79% on 1,000 watts at 100 feet run. Let's see what our 400 gets. So there you go. LMR 400 is going to jump you up to 864 watts out. So pretty good. Obviously, you're going to have some sort of loss with any kind of coax cable. Just for example, we'll look, even with the Andrews type Heliax with a 1/2 inch, you're probably going to have some loss, which would be way overkill for a 1,000 watt amp. If you were only running 1,000 watts and you're running 1/2 inch, the only reason I would see to do something like that is if you have a extended run of coax, like over 150 feet. And we'll mess around with this counter and discuss that a little bit. Yeah, so 92%, 93% of your power getting out. And that's going to be not noticeable. That loss is not even going to be noticeable. 75 watts on 1,000, you're never even going to know. So let's take it a step further. I was initially going to just do that with the small type cables, but let's step it up. And let's say we're going to run 5,000 watts and we were going to do 150 feet. Let's not do it in small increments. Let's just go there. Now, 213, do I recommend really putting 5,000 watts for it? Probably not, especially at 150 feet. But let's just say we were. We didn't listen to what anybody else had to say, and we decided we're going to hook a 24 pill up to a run of 213. We got 150 feet. We got 5,000 watts going through it. And by the time we get to our antenna, we're only putting out 3,484 watts, roughly. Now, I don't know about you guys, but if you spent the money to buy a 5,000 watt amp and come to find out that what you were seeing on your watt meter wasn't accurate and you were only getting 3,400 watts out, it's pretty disappointing. That's why it's very important to invest as much as you can in your antenna and coax. When people tell you that antenna and coax are the most important part, they're not lying to you. I mean, you could go crazy with this. You could go crazy with this, and you can't put 50,000 watts through 213, but if you did, only 34,000 of it would be making it to the end. No, let's not go that crazy. That's just a comparison, though. You're losing a lot of money that way. You're not getting your investment. I know, me, if you said, well, if you go and put $5,000 into the bank, and by the time it gets to the bank and gets into your account, there's only going to be 3,400 there, or 3,500. I don't think I would take that deal. Same thing with radio. You want to get as much to the antenna as possible. That is somewhere you can make a big difference at. Sometimes you can't help your location. There's other factors that you can't really help, but what you can help is buying the best coax available and putting up a good antenna. Okay, carrying on. Let's not get too sidetracked. So we're just going to step it up to 400. Now keep in mind, that's our 213 number right there, 3,484. But let's say we ran LMR 400 for 150 feet, 4,000 watts out. That's still kind of lossy, okay? You're still losing 1,000 watts PEP. And I know some people are going to say, that's not really make or break. It sounds like a lot, but it's not as much as it sounds like. It's still a good bit of loss. Almost a fifth of your power is not making it to the antenna, okay? And again, it goes back to that, getting what you pay for. If you do this to yourself, you're not really getting what you pay for. So let's say we want to step it up and we want to use the 1/2 inch Heliax at 150 feet. That's getting more like it, almost 4,500 watts out, 4,447 out of the 5,000 watts. So that's getting, more along the lines of something we can deal with there. So, and again, we can, do it with the 7/8. Again, most people running 5,000 watts aren't going to run 7/8. And this can be average or peak power, okay? It's just a percentage based. So, you can say, well, that's average power, peak power, whatever. It jumps it up to almost 4,700 if we use the 7/8. Okay. Let's look at one more long run, and then we'll see if there's any difference on short runs of coax, if it's really worth it. Like 18 feet, 15 feet, your mobile type stuff. But let's go and say we're going to run 250 feet. And because we're stepping up that high, we're going to assume that we're running some big power, relatively big power. So we'll say we're running 10,000 watts. and use your imagination, PEP or average. And we'll just start with LMR 400 just for the sake of it. We're probably killing our 400. It's starting to get hot. It's not locking that much power, but we're doing it anyway. What I do, I put a comma in there and it thought it was a dang decimal point. Okay. So there you go, 10,000 watts going in to the coax. By the time you get to the end of it, almost 7,000 watts out. And this, keep in mind, this is a long run, 250 feet. That's more than most people are going to run. But again, I mentioned in the other video, if you are going to have a long run like that, I would certainly, at the bare minimum, go with like 1/2 inch. Okay, which you see steps it up to 8,225. That's our 1/2 inch heliax. And then here is going to be our 7/8, which steps it up to almost 90% of our power getting out. And that would be my own personal goal. You know, guys, from my station, if 90% of my power is getting out, that's something you can probably live with. Again, you're going to have a little bit of loss no matter what, you know, and the difference in feet, I mean, it makes a difference too. Let's just change that. That gives you about 92% of your power out. So even at 200 feet, I mean, how many feet do we have to go down to where almost 100% gets out? We're talking about 7/8 here at 50 feet. We're still losing 200 watts. So almost no kind of cable you get, can you say that 100% of your transmitted power is going to make it to the antenna? But you can get dadgum close to where it's really not even noticeable. Now, as far as that goes, let's just mess with it here, and we'll go back to our, let's just say 2,000 watts for this one. And we're going to go down to 18 feet, the most common used length of mobile coax. And let's do RG8X. So, I mean, that's something you can actually, that's not too bad. At 18 feet, you see, versus when we were looking at it at 100 feet, see how much it drops off, this little coax does when you start stretching it out for long lengths? You know, something that's a good coax at 18 feet, where you're only losing 125 watts at 100 feet, turns into a bad coax where you're losing 600 watts. So let's go back to our 18. Let's see. MR240. You know, the difference is going to be very small when you're running, you know, these lengths of coax. Where's our 213 at? I can't see the forest for the trees. There it is. You know, 1900 watts. And then LMR 400, you know, 1948. So when you're running these 18 feet lengths, 15 foot lengths, it's really not going to matter. The loss isn't going to be that important. What's more important here is going to be your power handling capability. So it's pretty much take your choice of coax when you're, you know, running in a mobile application. The loss isn't going to be as big a factor because you guys saw, even with something like our little RG8X coax, you don't have a lot of loss. You just want something that's shielded well and that's going to handle the power that you're putting out in the mobile. Because almost any of your coax that you're going to run, they're not going to have a lot of loss. Now, there's other options out there that I didn't cover, as I mentioned in the other video, and they don't even have it on this counter, so we couldn't go over it if we wanted to. Something like the RG400 that has become very, very popular. RG393 is a high-power Teflon coax. It's a little lossy, but it handles a ton of power. Stuff like that. We're not going to go over it. Just keeping it pretty simple for you guys. Again, you can look up different loss calculators, coax calculators online. You might find one that you like better. This one's pretty good for a quick reference. Has a lot of the common stuff. Some of the older stuff that's been used for years, you can kind of just see where you're at with it. Especially like the heliax. Yes, they've changed the branding of it, the type of the style of it a little bit. This is just the older version. It's basically going to be the same. Matter of fact, the new stuff may be just a little bit better as far as loss goes, but it's going to be pretty close. Okay, appreciate it, guys. Another long video here, so hopefully share some input. Let me know what you guys think about it. If it's helpful, not helpful. Huge waste of time. Best thing you've ever listened to. Whatever. Everybody have a good one out there. Rooster in Tennessee. RoosterCB.com. Thanks, everybody. See you. Bye.